Hello, this is Mr. Stein, and in this video we're going to take a look at the vocabulary and the basics for section 7.4, using a substitution strategy to solve a system of linear equations. After you've done this section, you should be able to isolate any variable in a linear function. Solve a system of linear equations by substituting in. First off, we're going to take a look at isolating a variable. So first in this equation, we're going to isolate our x variable, then we're going to isolate our y variable. So let's start off by isolating our x. We're going to do this one in pink. And rewrite it out. X over 2 plus 3 equals 3y minus 5. All right, first thing we need to do is we need to get rid of this plus 3 here. So we subtract 3 from both sides to get x over 2 is equal to 3y plus 8. Now our variable x is being divided by 2. So to cancel that out, we have to multiply this whole equation by 2. We multiply the 2 to every term in the equation. As long as we multiply every term by 2, we maintain an equivalent equation. So we get x is equal to 6y. And now I sure hope you notice that it's not plus 8. It really should be minus 8 now, shouldn't it? Because negative 3 take away 5 makes this guy minus 8. So minus 16. And right there, we've isolated x. Okay, now let's isolate y. We're going to do that over here. We'll do that in blue. Let's write out our equation. X over 2 plus 3 equals 3y minus 5. So let's add 5 to both sides to get 3y is equal to x over 2 plus 8. Now our variable y is being multiplied by 3, so to get rid of that we have to divide by 3. And to do that we have to divide each term here by 3. So we're going to be left with y is equal to x over 6, x over 2 divided by 3. That was x over 2 divided by 3. Now we do 8 divided by 3. 8 divided by 3 is a decimal number. So I just leave it as a fraction. And there is our y isolated. You should be able to take any linear function, any linear equation in two variables, and isolate either variable. Now, the important bit. Substituting in. So when we get a system of linear equations, which we have here, we have one equation and its related equation. We can substitute one equation into the other. You can see over here that x is equal to 2y. So in this equation where we have x in our equation on the right, we can take and we can put in this 2y because x is equal to 2y. So we take this 2y minus 1, and we take it and we substitute it in for x, because x is the same thing as 2y plus 1. So we take this 2y plus 1, and we substitute it in for x, because it is the same thing as x. So then we get 2, and instead of x, we now put in this 2y minus 1. Plus 3y is equal to 1. Now what we've done is we've taken this equation over here that had two variables in it, x and y. Now we've turned it into this equation that has one variable in it. So now we can solve this. So we multiply the 2 into each term to get 4y minus 2 plus 3y equals 1. Now we can actually solve what y is. So we combine our y's together to get 7y minus 2 is equal to 1. And then that changes to 7y is equal to 3, and y is equal to 3 over 7. So now we've solved out what value of y solves both of these equations. Because what we did was we isolated a variable x, then we took what that x was equal to, and we put it into the other equation. All right, so down here at the bottom, I've just given you some basic practice. You want to find the variable that is easiest to isolate and isolate it. Okay, so that's what you're looking to do here. And in the first one, y is easy to isolate. I just moved my 3x over. So you're always looking for which variable is easiest to isolate. In my second one, it doesn't really look like either one is all that easy to isolate. So here's what I'm going to do. I'm going to take all my y's and move them to one side, and all my x's and move them to the other side. So I'm going to get 4x minus 3x is equal to 8y plus 3y minus 9. Now it looks like my x is easy to isolate because 4x minus 3x is x. 11y minus 9. So this x ended up being the easiest to isolate. The third one, we identify which one's easiest to isolate. Well, let's isolate this x because it's already kind of by itself. So we're multiplying x by negative 6. So we need to divide x by negative 6. We need to divide everything over here by negative 6. So these will cancel and we'll be left with x. And then we look at this side, 4y divided by negative 6. That's going to be negative 2 over 3y. And then we look at this guy here, negative 20 divided by negative 6. And that's going to be plus 10 over 3. And there we go. We've isolated x. Let's look at this one. Which variable is easier to isolate? Well, I don't really know, actually. But I don't like having this fraction here. So we multiply both sides by x. Those will cancel, and we get 3y is equal to 6x. Now, which side's easier to isolate? The y is actually easier. Divide both sides by 3 to get y is equal to 2x. All right, in this one, which one's easier to isolate? Well, honestly, the first thing I see is I see this fraction. I'm like, I don't want that fraction there. If I can get rid of the fraction, that'll make my life easier. So I take this whole side and multiply it by 4. And if I multiply one side by 4, I have to multiply the whole other side by 4. And then this 4 and this 4 are going to cancel out, and we'll be left with y plus 1 is equal to 8x plus 20. Oh, now it's easy to identify that the y is much easier to isolate. So y is equal to 8x plus 19. Done. We've isolated y. All right. So in the examples, we're going to go through the steps of substituting in, using substitution to solve a system of linear equations. We are going to, number 1, identify which variable to isolate. Isolate it. Then we take that and we substitute it into the other equation and solve it. And then after we solve for one variable, we have to solve for the second variable. So we're going to be doing that in the next section in all the examples. All right, I hope this was helpful for you. I hope you understood it. If you have any questions, please put them in the comments below or contact me directly, and thank you for watching.